could be one block of your entire system. So maybe in this highway lane following design, vision detector could be one thing where you are trying to detect certain things. But you have other blocks as well, which is analyzing the 3D scenario, some sensor fusion blocks, some controller block, vehicle dynamic metrics all together are needed to make your entire system. So this is more of an interest and in industrial applications to do these kind of system level design. And after which they can do the system level simulation as well. So we have some Unreal Engine Roadrunners framework, which helps the autonomous people allow them to do that system level simulation of their system prior to deployment. Okay. So vision detector becomes the only block which is probably using the AI modeling, and it is one part of the entire system. And from here, once the verification validation is completed, then we go for the final step of deployment to CPU or a GPU or FPGA board using the code generation workflows. So we saw about deep learning, which is a subset of machine learning, and which is neural networks with many hidden layers. So basically, in this slide, you can see that deep learning can learn directly from data. So you may not have to create manual feature extraction or create or generate feature manually. But it is again computationally intensive and need more data. So only when you have more data, then you will be able to develop such model, and it is not interpretable. So by not interpretable, it means because you're not developing the features by yourself, so the model is able to generate the features by itself. So you are not putting much effort in interpreting what kind of features would be better, unlike as in the case of machine learning. So this is the difference of the same application. You want to identify a car, but for the machine learning model, you have to do a manual feature extraction step to give those features. But in this case, you can directly give the raw image to the CNN. So we saw the 5 lines of code. So also if you, so in this image, basically they have just used the webcam instead of loading an image, and they're capturing the image using the snapshot command, and using the camera, USB camera that is connected, they're trying to identify the objects. Okay, the same AlexNet network. So they have these labels as well inside the 1000. Then there are more architectures like some signal processing architectures like recurrent neural networks. Some examples are of some a famous RNN is known as LSTM as well. Okay, so and the other one is on CNN. So the both are complex deep neural networks. So one is more suitable towards time series data analysis directly, and the other is more suitable towards images. So in this case, as you are seeing, we are using a similar data set here, a time series data. If we want to use this for a CNN, then we need to do another step to convert it to a kind of image. So one useful way to do that is to get a spectrogram, okay, which looks like an image containing the frequency and time axis and the energy of the signal inside it. So that itself becomes an image. or else the other architecture which works differently could be used to address these applications, address multiple applications. So these are broadly classified. Next, what we will do is that we will, let me just check the time. It's 27. Okay, yeah. We are. So yesterday was human activity classification covered using machine learning? Or at this point, probably we can take some questions, because I think I have been speaking one way. So you may have some questions at your end, which you may forget. So before going to this demo, I guess we can have some Q&A for maybe 5 minutes or so, and then we can again continue.
Okay, sir. Okay, sir.
Okay. So any questions, anyone? I see some participants have raised their hand. Okay, I see no, sir. Okay, so okay. Rajani says we do not have any question, but till now, whatever, if are you able to follow, you can also mention those comments as well. So it will give me an understanding that if you are able to follow, or if you want me to repeat certain things. Okay, yes, thank you for the comment. So it can be from yesterday's session as well as today's session. Any questions that is in your mind, or anything you want clarification on, you can just mention that. Clear, sir. Okay, thanks for the comment. Okay, it is good to know it is clear. Thanks, Ragashri. I am a non-IT person. Okay. So that is actually, yes, but very okay. I am not a non-IT person, but very clear. Okay, that is a very good comment. Yeah, thanks for that. Actually, we want to enable everyone. So the Gartner quadrant that was shown earlier. So the main reason MathWorks is in the leaders quadrant. So anyone can use AI in their respective domains. So if you are a non-IT person, but if your application needs AI, so we would be happy if you can use or make use of these tools and focus on your domain knowledge. Yeah, thanks for that comment, Nanda. Me as well, clear, sir. Okay, sure. So most of you are able to follow it, and I don't see any specific questions. So let me then go to the next part. So next part, I will again quickly go to the MATLAB window. So we saw the 5 lines of code earlier. Now Again, there is another folder on low code AI. Let me just, oh yeah, all the, it is inside the path only. No need to worry. Okay, so the problem is pretty much clear, I guess, but just telling again. So you have a smartphone, which is, which can be Android, iOS. So any smartphone will have sensors. So by sensors, I'm not talking only about audio or camera, so which is anyways there, but other sensors, motion sensors like accelerometer and gyroscope and so on. So these sensors will collect data when it is attached to the human body with time, and that data needs to be analyzed. Okay, so it can be analyzed using machine learning, deep learning, okay, in different ways. So today we will try to use that data using a deep learning model and try to classify. Okay, this is a supervised problem again. So we already know the labels. So we want to classify it based on that. So data set is taken from this reference paper mentioned here. And so this is the program in the form of live script. So all these are text. So in the first section, we only have one command to clear. So I am not clearing it right now. I just ran this entire thing earlier. Let me go through the sections. The first section, we only have the index, and the second section, we are actually loading the data. Okay, so the data set is stored in a mat file, which is inside this path, divided into train and test. So both the data set are loaded, and we are converting it into a tabular form. So using the table function. So once we convert that, then we will have a structure like this. So for example, if we are talking about raw data train, then we will have 6 sensors. So like sensor 1 is the accelerometer, sensor 2 is the gyroscope, and we have X, Y, Z directions for both of them. So that's why we will have 6 such columns, and each column will have around 128 data points. So what are these 128 data points? So these are the samples. So we are measuring the 128 data samples in 2.5-second duration. So depending on the collection or the sampling frequency, we are collecting 128 such data stamps in 2.5 seconds, and that is all stored here. And the other axis activity is the type of activity. So there are around 7,352 activities, which is divided into all these 5 classes. Okay, so this is the structure of the trained data. So yesterday you have learned machine learning, so very easily you can use this directly to your app in use the classification learner app to do the machine learning classification or create the machine learning model. But in case you want to explore deep learning, then you have to use the deep network designer app, the second one. Okay, but for that you need to understand a bit more on the, depending on the type of deep neural network you want to use. So for in this case, if you are using an LSTM, so for LSTM, the input structure has to be changed to a different format. So that has been done using a helper function, a group by activity function, which takes the raw data and the number of signals and arguments, and it will return you or just rephrase the data set into a different format. So you see, this table has been changed to this table, but the data set is same in a different format. So here you have activity in each of the dimension. Okay, so from activity 1 to 7,352, and if you see the first frame of image kind of thing, or the first frame of matrix, you will have the 128 samples here and the 6 sensors in this way. Okay, so this kind of dimension can be fed to LSTM model. So that is why we have just done that. Now we need to open the Deep Network Designer app. So let me open it, or if it is already opened, I can, yeah. So I just did the training part earlier just to save some time, because it takes some time to train on non-GPU system as we are doing with deep learning. But let me show you so that you can also follow it from scratch. So what you have to do next is Deep Network Designer. So you can type Deep Network tab, you will get the app name. So this is one way. Or the other way, you can just select this Deep Network Designer app. So once you open this app, you have to just select a new frame where you will get a blank template. So in this case, we have made the LSTM, simple LSTM structure by dragging and dropping this sequence input layer, then the by LSTM layer. So you need to have some understanding, or not some, you will need to have full understanding of the model that you are trying to build. So what are the dimensions that you need to provide? Okay, and the corresponding layer. After which you can simply connect these layers and the classification layer. Okay, so these are the 5 layers, so which is already taken here. So I'm deleting this one, and after that you join them, and you will have to mention the properties like input size. So there are 6 sensors, so you have to mention it 6. So there are 128 samples, as you saw in per metric. So you have to mention that parameter. Again, the output size 6. Softmax will do the classification output, a simple LSTM layer. Then you go to the second tab where you import the data. So data was imported using the image import data store option. So it is already imported. Like if you click on import, you will get this option where you can import the training data out here. And after it is imported, you will go to the third tab for training. So this took me around 19 minutes, 27 seconds in my computer. But if you have a GPU, it will take around 2 minutes or less than 2 minutes. Okay. So before even training, you have to just go to the training option. And this is the place again where you need some knowledge on what kind of solver would be appropriate, what should be the learning rate. More often, initially, you may not have a good intuition or which parameters or hyper parameters you should change. So you will play with the learning rate itself at the very beginning, because this is very important. High or low value may not help your network, so you should choose it accordingly. And after which you have other advanced parameters for regularization and other aspects. Okay, so once this is completed, you can then start training, and after training, you will get this result. So we have not selected the validation option here. So validation is to avoid overfitting. So in case it is selected, it will also add another curve for validation as shown here. It is not there currently, and you will be able to train it. And finally, you can export the trained network and results, export the code. So if you are from an CS department, IT department, you are more interested in the code, you can just generate the code also. So you can just generate the code, which will be generated in the form of a live script. So this is the live script for training the model. So here you will find the commands which are used. So the training options function is used, the layers function is used to create the network, and the train network is used to train the model. Okay, the code version of the same. So this is also available. So if you want to know that, or you can directly export the train network and results. So for the industry people, like they want to go to the testing stage, so they export this into the Simulink for the system level design. And also you can use the experiment manager. So this is another app which is further used to tweak the hyperparameters in an automated fashion to give you a best model. Okay, it will take a lot of time in the searching process. So once you are final with some model, then you can use the experiment manager to get the best model after doing hyperparameter tuning. All these options are there. And yeah, so this is the train network after exporting here. And finally, you are using that train network and the data store test data to classify using this function. You are getting an 88% accuracy. So more than accuracy, you will also get a chance to, it is important to see the confusion chart. So has anyone heard about confusion chart? Yes or no in the chat window? Or if you know, you can tell what is a confusion chart, why it is important. So if you have heard about confusion chart, you can type a yes. If you have not, you can type a no. No, sir. Okay. Some more responses, because this is a very common metric in these applications. So in case you have heard, I haven't heard it before. Okay. No, sir. Okay. Till now, I haven't got any yes. All of them are new to confusion matrix. Okay. So very easily explaining it, so when we are talking about accuracy on the test data, so we are talking about the entire data set. So the entire data set was divided into 5 labels. Okay, these are the 5 labels: walking, upstairs, sitting, standing, sleeping. So when we are plotting the matrix, okay, with respect to the labels, so we have 2 classes, true classes versus predicted class. Then whatever is in the diagonal, so these are the correct predictions. So the predicted class and the true class are same. Both are walking. So 455 times we have done the correct prediction. The other times are the incorrect prediction. So this gives us more insight in addition to the overall accuracy. So you can understand the false negative, false positive rate. Okay. Is it about standard deviation? Okay. So I won't say about standard deviation, but in one way you can say you are trying to understand it, a kind of deviation or similarity between the predictions of similar classes. For example, if you talk about the first 3 classes where we have more missed classification, okay, or you can see sitting and standing. When we are talking about sitting and standing, so because we are not moving, so whenever we are standing or sitting, so that is a stable position. So here we are having more misclassification, 107 and 89. Okay. Similarly, when we are walking, so this is a moving activity, but we are either walking on a straight path or upstairs or downstairs. Okay. So there are some similarities because of which we are having these misclassifications. So 32 times it has predicted walking when the person was walking upstairs. Okay, so this insight you will get. And this insight is important in some critical application where you actually want to reduce these misclassification errors. Okay, it has to be 0, especially in medical application. So suppose just simplifying this into a smaller problem. If you want to predict a person is suffering from cancer or not, so you don't want to predict wrongly. If a person is suffering from cancer, and if there is a wrong prediction, no, the person is not suffering, then that's a critical scenario. Okay, so you don't want that. So in that case, you want to reduce these misclassification errors. So this is the importance of confusion matrix. As the next step, so you have, I guess you have got a gist of the entire thing. You can experiment more on the experiment manager and other aspects. Now, let me quickly also highlight certain more things, because you already have a mobile phone and we have some ready-made examples on human activity recognition, which is deployed in that mobile phone. You can probably go over the link. You need to do certain additional steps like installing the Android support package if you have an Android phone. And once you do that, you can probably collect your own data as well and run the already designed Simulink model and generate the compatible code for your Android device. And you will have an app something like this. In this case, there are only 3 sensors. There is no gyroscope present in this particular phone. So if you have gyroscope, then probably you will have a better prediction with more sensors. So based on the response, this accelerometer values will change the acceleration depending on that, and it will predict the output value. Yes. Yeah, it is based on the prediction of human activity. Yes. Yeah, you are correct. So here also, it is just taking this accelerometer values in real time as data, and it is now it has changed to sitting, again walking, okay, and giving the predictions. So this is after training. You are just deploying the model into your hardware. So you can try these at your ends also, which gives you an very easy way to go over this end-to-end workflow from data prep to deployment. Now, I would like, I think, Shovik is in the call, I guess. Shovik, are you there?
Yes. Can you hear me?
I can hear you. Can you move the mic closer?
Yeah. Give me 1 second. I'm just changing the headphone.
Okay, let me know if I'm audible now.
Yes, pretty clear. I
Okay.
can hear you.
Thanks, Anand, and thank you everybody for being here. Yeah, we can talk about a little bit on this example, but before that, it's good that you all of you are pretty interactive in the chat window, and you are mentioning there about what you think about many of the things. So why not let's use that in the beginning. So Anand asked in the beginning what you learned yesterday. So the question again, what did you learn so far now? If you want to put in the chat window, what is the one thing that I know that you learned a lot of things, but what is the key thing that will be applied, that will be useful for you? Like whatever you are doing in terms of your course or research or anything you want to do, what is one thing that you have learned today and you want to explore more for anything that you want to do as a project, as a course, as a research, AI for assessment? Interesting. Thanks. Great. That's what you can put in the chat window. It'll be good to know, and we can discuss on that also. AI for assessment. That's an interesting proposition. Anybody else? Any other thoughts? So if you realize, we from Rakshit's end, it was mostly machine learning yesterday, and today Anand covered on the deep learning aspect. Both of them are part of the AI, which we call, right? So okay, a question now, quiz. What do you think? I mean, I know this has been covered also, but now that you have learned a little bit about machine learning, a little bit about deep learning, to your mind, what do you think about the difference between machine learning and deep learning? Anybody wants to highlight that? You can just put in the chat window whatever you think is correct. I'll stop the video too. AI in weather forecasting. Nice. Yeah, that's of course a very nice application. There are lots of examples on that. We have covered a lot of examples on, prediction of temperature, forecasting weather in multiple different ways, which we can do based on the data that we have. Right. And of course, we can share some, resources and things, how to do that. We have a lot of examples on AI for weather forecasting, which is definitely useful. Um, okay, so on the question, what is the difference between machine learning and deep learning? Any thoughts, any guesses, anybody wants to take an attempt to that question? Machine learning works with actual data, but deep learning works with raw data. Well, that's, I mean, true and not true, I'd say, because both works with data, right? And I mean, I don't know what you mean by difference between the raw data and actual data. I mean, both are data, right? And both have their own way. So there can be data in the form of numbers, there can be data in the form of images. So there can be all these different type of data that you can work with, and all are data. So it's not like one of them is sort of simulated data. You can work with simulated data, but that is all. Amthul's answer is correct. Huge data is dealt in deep learning. In deep learning, we deal with more data than machine learning generally. Deep learning, Dr. Vanita's also is correct that we do deep learning with more layers. So we use different type of layers. Like if you recall the example that Anand was showing, there were different sort of those layers that we created. There are input layers, there are LSTM layers, there are a bunch of different layers that we use. Deep learning is algorithm. Well, that both of them are algorithm. AI in food safety. Okay, Gayatri, that's a very nice area. Definitely, there is a lot of scope there in terms of food technologies. We have one example which we generally talk about of identifying food, right? Say for example, imagine there is a CCTV camera, and then you want to just identify the quality of the food that is created in some maybe a process industry or something. When say the quality of the milk or quality of any cheese or something that is created. So using those images, we can do that and having the algorithm. So that's also a very nice application. Yeah, both of them are algorithms. So algorithm is there in common in both of them. Machine learning is related to label data and needs small data, but deep learning is still absolutely, you are correct. I mean, deep learning also needs label data, but yeah, we need huge data. Karma. Noor Fatima, yeah, you're correct that machine learning also deals with algorithm. Okay, great. Thank you for all the responses. It's great to have interactions, because we don't want to spend 2-3 hours just, a couple of people from our end talking. It doesn't feel right. Um, okay, grading and sorting of fruits using image processing. Absolutely correct. We can definitely do that. There are lots of examples. I think we can share some example links as well. Food identification, image processing, MATLAB. So there are examples on that where you can identify foods using deep learning. And yeah, so that is one area which we can definitely do. And so when you do image processing, I have missed it, but have you done the AlexNet? Anand, were you able to show the AlexNet thing? Anybody else also?
Sorry, I was on mute.
Sorry.
Yeah,
Yeah.
I've shown the LXNet thing
Sure.
on the butterfly, the pre-trained
Sure.
one. Yeah.
Right. Thanks. So Shubhasini, so if you have seen AlexNet part, so similar thing you can do also for grading and sorting of fruits. So when you have images, we can do the image processing on them. We can create our own networks. We can use pre-trained networks and do that. Segmentation cancer cell along with COVID-19 patients. Yes, as a very nice example. There is one example which we did about using X-ray patient images of X-ray of patients, and based on the X-rays, if we can classify whether the patient is COVID-19 positive or not, uh, by training of the chest X-ray images. So that is a classic example we have. I mean, I can show that example also. There are lots of examples. We can, I can show one of these, but these are all there. And I know it is understandable that every one of you have your own application area. And if you want any specific application for any specific, area, let us know. I mean, definitely we can share those things later on, um, which we can definitely share. Um, okay. So coming back to yeah, I'll try to figure out the COVID-19 example. I'll find out that in the
So one
meantime.
thing I
Yeah,
wanted
sure.
to add on that previous comment of actual data in machine learning and raw data in deep learning. So here by raw data, you're partly correct. So if you have a raw data like a raw image file, you can directly go with deep learning approaches if you have a large data set. But by actual data, like uh, if you are mentioning about extracting some useful information out of the data, which is also known as sometimes features, then that could be the actual data if you are referring actual data to that for your machine learning application. So that is one thing I just wanted to uh, add.
Yeah, there is one question. Can you please specify a particular example to differentiate ML and DL to understand the difference well? Okay. Um, let's see. Let's think about an example. Now, I mean, you have learned yesterday and today about different things of machine learning and deep learning. In machine learning, if you recall, what have we done? In machine learning, you have seen things like ECG detection, right? So that's one example which you have seen yesterday. I'm just looking into what you have seen yesterday. So you've worked with classification and regressions. So then say if you have the data, right? You have data. Then if say signal data you have. So from the signal data, first thing what we need to do is from the data, we need to find out what can be differentiating features, right? So now what can be differentiating features from a time series data? Um, so if you have any time series, like remember the human activity. Okay, let's take the human activity because you've just seen that. So human activity data, say you take the data from your phone, from your smartphone. Now, if our objective is to classify whether a person is walking or standing or sitting, that sort of things, how can we do that? So you get the data. Now, one approach is once we get the data, we try to find out what is the difference between the data, say between when I'm walking and when I am standing. So what can we see when we have a gyroscope in our hand, whenever we have an accelerometer, when we are standing, we will have a different, I mean, it will be zero. It's probably just acceleration due to gravity. And when you're walking in X direction, you have an acceleration. When you are going down, you have a different acceleration. So you have this different time series data for different type of movement. Now, if we have to differentiate the activities, our final objective is same. We want to classify. We want to classify based on the data whether we are walking or standing or walking upstairs or what. Now, all of these things are called labeled. So if you have this labeled data initially, so labeled data means whenever you are doing an activity, so say for example, you know now that you're walking. So this is your labeled data and you switch on your smartphone and you get the data. So that is a data which is labeled for walking. Similarly, you have the data for sitting. Similarly, you have data for standing. So like this, you get the data. Now from the data, we have to differentiate how the data is when you are walking versus when the data is when you are standing or walking upstairs. Now, how can we do that? Maybe we can find out the mean, standard deviation, or we can go from time series to frequency domain, do a FFT, find out the peak frequency, the dominating power spectrum value, all these things we find out. And based on those features, we say, okay, so when these features are like this, then it is walking. When these features are like this, then it is standing, like that. Now, what we can do is, based on this feature data, so you have this feature data now. So then you go to the classification learner app, which we have seen. And then from there, you create an algorithm, because again, remember, both machine learning and deep learning has algorithm. So there you go to some the classification learner app, and then based on your feature data, remember, based on your feature data, the feature that you have extracted, based on that, you are classifying your data. So this is machine learning. So near here, if you recall what we have done, we have used our own expertise to identify the features. Now, what can we do for deep learning? In deep learning, you create a layer, a network, like that LSTM network that Anand showed you. So you create that network, and then you use the algorithm, you tune the parameters and everything. But here, you are not doing that feature extraction part of the FFTs and all. You get the data, you pass on through the network, and then you do the final classification task remains same, right? Does that make sense? You can put a yes or no or any clarification. Anand, also feel free to add anything on this.
Yes. So like you already mentioned it. So the basic difference, like if you're considering the human activity recognition problem, is to extract some features out of the data. So the problem that we just saw, we were using all the 128 samples directly in the data set. But if you want to do the same problem using machine learning, as Shobik was mentioning, you may extract the statistical features like mean, standard deviation, and other parameters out of the 128 samples, which will reduce the uh, input data dimension, or the feature vector, you can also say, to a smaller number depending on the number of features. Or obviously, if that is reduced, then your model complexity will also be a smaller one. An ML model can be a good enough model to train such things. So you have to put extra effort on the feature engineering steps if you are going with a machine learning approach. Yeah.
Okay.
So yeah, you have mentioned, I think, yes, sir. Okay, thanks.
Sure. Thank you, everybody. Okay. So maybe I'll share the screen and quickly go over a couple of more examples. And then you have been listening to things for around 2 hours. So we won't probably continue for the entire hour. We also want you to do some hands-on if possible. So that we'll try to see if we can do that in the end. But I'll show the COVID-19 example maybe initially, because that was you asked for, and then we can go the engine one. So the engine one, the slide that is here, this is one of those very core company which looks like very mechanical, electrical production type focused, right? Now, one thing we need to, I mean, I personally am from a mechanical background, and then we need to make sure that these things, AI, machine learning, deep learning, these are not really always focused for computer science or that way. This is there for every department. For science, like as somebody mentioned, weather forecasting. We have some examples on tsunami forecasting, food processing. So it goes everywhere as long as we have data, right? I mean, it can work without data as well, which goes to the area of reinforcement learning, and very classical in robotics type of applications. But the idea is, if you are in a core engineering or science domain, we need to make sure that this AI thing is for everybody. Of course, if you think about example like Facebook or Netflix or Amazon, there it is more about computer science focus, because if you think about Facebook, it's just is doing facial recognition, right? But if you look into the example that is there in this slide, which is in an engine sound. So imagine, in a factory floor or in our own home, we have pumps, right? Pumps which transport water from the bottom to the overhead tank. Now, if there is a very experienced person, they might listen to the sound of the pump and say, okay, this pump is not working well. There is something wrong, right? But and not a person who is not an expert will not be able to do that. But imagine you have a situation that there is an algorithm and in your phone, and you take your phone to the pump, and then the algorithm will tell whether this pump is working fine or there is a chance that this pump might fail. Uh, Now this is what this is precisely has been happening in this slide here. So this was used for to classify engine sounds, because car engine sounds are also tricky, right? From there, if you know some concepts like knocking and all, they create very weird sounds, and from there we can figure out whether this engine is actually faulty or not. And the process to do that is the same. Like the human activity recognition, we get data with the ground truth, or you label the data, and from there we know which is a normal sound or somebody which faulty sound, and then we create for signals. We always create this LSTM network, train the network, and then we follow the process. So the workflow remains same for deep learning, but this sort of application also works. Okay. Okay, so network issue is not able to listen properly. Just to make sure, Anand, am I audible, by the way?
I can hear you very clearly. I think
Okay,
the network
thanks.
issue will be on their end.
Sure.
And the session is recorded, I think.
Yeah, it's
I'm
saying
not
it's
sure about
recording.
that. I think it is recorded. It is
Yeah, but
recording to the cloud. Yeah.
okay. So I'll share the screen now. Can I have the sharing access, please?
Let me stop sharing
Yeah,
then. Okay.
thanks.
Yeah.
I think the host needs to enable sharing for me. Um, can I please have the access to share screen?
I'm the co-host. I'm not sure if I also have the option.
Yeah, you are the co-host. I don't know how. If there is an option to, yeah, it's still showing disabled. Anand, are you able to?
No, I don't
think,
have that option. I
okay.
think the host
Host
will have the
Shivani,
option.
if you are there. In case of which, how do we do this? Anand, do you have any demos which, how do we do this?
That do we do not have the host right now.
Shivani, are you there? It's not there.
Or should we give a 5-minute break and maybe try to resume after that?
Yeah, how long do we have? Do we know? I mean, the PDF also shares till 6, so I'm not.
Oh, is it still 6:22? Okay, yes.
Jayanti ma'am or anybody from the host from Jain University, do we have in the call to confirm on the time? And 4 to 6. Okay, so we are sort of out of time also then.
Oh, okay.
Okay.
Then I can share the slide.
Yeah, then if you can share the slide and maybe show the on ramps, maybe we can just end there.
Sure.
Okay. Thanks, Nanda.
So I am sharing my screen. Is it visible?
Yes.
Okay. So we are out of time. So basically, so I hope these are the key takeaways were met today. Like the importance of AI in different applications, when to use ML and DL. Just one slide which gives you more clarity on this. I just want to highlight this. So if you have more knowledge of your domain, then you will be able to extract better features out of it, and you can use low complex machine learning models. On the other end, if you have less domain knowledge, then you go for deep learning methods using raw data. But for that, you need a large data set and more computation for hardware because of the complex model. So these are the two extremes, and there are some in between ways to also go over this. So these are the apps like different labeling apps, experiment manager to find the best model after multiple iterations or multiple combinations of hyperparameters, and some expo talks also. Recently, we concluded our expo conference. So there are some talks related to AI. You can watch the recordings as well. For the challenges thing, so there is this mini drone competition as very good. So this is happening for the second time in India. So there is no participation fees, and there are two rounds. So the first round will be a simulation round where if you are qualified, then you can go for the second round at IIT Kanpur, where you will be provided the mini drone hardware. So you can decide on your team and apply it by July 29. So there is a projects page as well. So in case you are interested, you can browse over some projects related to AI as well. So there is one on human motion recognition using IMU sensor. So you can visit the GitHub page for MathWorks Excellence in Innovation. And there are many learning resources starting from pre-recorded videos, webinars, tutorials, question answer forums to address the queries of all the users of the community. Okay, in MATLAB Central, the on-ramps will be a great place to get started to have a hands-on experience. So we have 11 on-ramps available. And with that, we also have instructor-led training in case you need. So it is in MATLAB Academy website. So let me just highlight you the on-ramp page. So with your account, if you log in into the Academy website, you will find these getting started on-ramps. And for AI, we have specifically 5 courses, 2 on-ramps, 2 full courses, and 1 on reinforcement learning. So you can start with the on-ramp, which is of 2-hour duration. But if you want to know more on the workflow, you can do the full course as well for machine learning as well as deep learning. Okay, so these are basically the same on-ramp resources, Coursera pages. So yeah, as we are over time, so we would request you to fill this feedback form. You can scan it, or there is a tiny URL also. Let me also try to paste it in the chat window. Okay, I've pasted me to hosts and panelists. So I should paste to everyone. Sorry. Okay, so I've posted the tiny URL link to everyone. So do let us know your feedback, your thoughts, suggestions, and in case you have any specific queries, you can mention that too. And yeah, so I see one hand raised. So if you have any questions, if you can unmute yourself, so that would be great. We can have some question answers now as well before ending the session.
I request all the participants to drop their questions in the chat box.
Thank you, Vanitha. So, So Shaileja, your hand is raised. So if you have any questions, uh, you can either type it in the chat or unmute yourself if that is available. So I believe most of them are filling the feedback form, so they are not having any questions now. So that is taking around some time. So any thoughts, comments, you can also add in the last question in the feedback form. So it will be useful for us uh, to curate our presentation in future.
Yeah, I think the questions also came as we went along. So
Yes. So that was very nice. The audience was pretty interactive throughout the session.
Yes, sir. I would like to request all the participants to kindly fill out the feedback form, and it is mandatory for the certificate. Link is posted in the chat box.
Okay, so I
So
see
one
one
question
question.
is there, sir.
Yeah.
Any paper related to weather forecasting showing any quantitative improvement using AI will be interesting, kind of.
Okay, sure. So one easy way, like I would try to find this is through Google Scholar. Like I will try to type maybe the keywords like weather forecasting plus AI, or if I'm more specific on machine learning, then machine learning plus deep learning. That will give me a good amount of results, and from there I can get an idea which ones to follow.
Yes,
So
the second one is like he's telling like you said like regarding the COVID patient X-ray you will show
okay,
simultaneously.
sure. So
Yes, sir.
yeah, the COVID one we were trying to show but we could not share the screen. Let me see if I can share the link. Yeah, so we have this model in something called file exchange. So in the file exchange, if you go to this link, there is a deep learning for detecting COVID-19 on chest X-ray. So you can go there, and that contains the entire model, the details.
Okay, sir.
There's a question on, are the on-ramp courses sufficient for learning, and will it prepare for exploring some research level questions? So one thing is the on-ramp courses are all hands-on courses. So if you look here, these are not lectures. These are like, it will give you some task, it will tell you how to do, and then if you do it correctly, it will go to the next task. So like that it will go. Now on ramps are of course for getting started. So this is when you know how to do, say, supervised learning, unsupervised learning, clustering, and machine learning. And of course in mathematics you can do a lot of things. There are a lot of things in mathematics. The other thing is, if you go for research level after doing the on ramp, you can also go for the other courses. Like, say for example, here if you see, there is a course on machine learning with MATLAB, right? So that course is a bigger level, advanced level course. This is around 14 hour, and everybody in Jain has access to that also. So that course, because the on ramps are free in general, but these bigger courses are not free, but with campus wide license you have access to these courses. So this will definitely prepare you for research level questions. Like this, there is machine learning, there is deep learning, there are courses on solving differential equations, nonlinear equations, all those things. For mathematics, those are very critical. All right.
Also here in the full courses, you will find some projects also in certain sections,
Yeah.
like a project on regression, a project on classification. So this will give more hands-on experience to deal other projects as well.
Yes. Hope that helps. I think also there are two feedback links. One is from the organization and one is from us. So it would be great if you can fill out
Oh, yeah.
both. Yeah.
So this one is the other one, the tiny URL and the barcode, and the
Yeah.
other one is, yeah.
Great. If there is nothing else, I think we can end the session.
Yes, one thing is like they're asking for interns, sir. Do you get to work as an intern?
Intern, okay. So there is official internship program, so that you can go to MathWorks webpage, and in the MathWorks webpage you can look for open positions. And one of them is, of course, if you look for internships, you can just go to MathWorks Explore Jobs Internships, and that will come up. So that's the official internship option. The other thing is, what you can do is, Anand, you can show the excellence in innovation as well after
Okay.
this. So the excellence in
Okay.
innovation, yeah, that's this is not really a physical internship, but nowadays we are not doing anything physical anyway. So this MathWorks excellence in innovation is a list of project ideas. These are industry relevant projects in different areas. There is AI, there is EVs, all these emerging trends, because based on our experience in working with industries, we have seen what they need. So what you can do is you can look into this and then find out a project that you want to do. The criteria here is, if a student wants to do it, there needs to be a faculty mentor. And the way this works is, you have to fill up this form, and then you can solve the problem. It tells you the way you have to go about it, like how to get started, which example you need to do before doing this, and so on. Now the thing is, you can treat it as a virtual internship, because if you complete this project, you get a certificate and recognition from MathWorks, and that you have completed this. We can recommend you into social media, the jobs and all. So this is also a nice thing which you can definitely try to do. Yes, Anand, feel free to add anything.
Yeah, here good thing is the project description is already mentioned, so you can browse over different projects and go through the steps, what are the things to be done, some background materials. So for in this case, they are using a data set by UC Irvine on human activity recognition. So basically, you have to start the project using this data set and try to accomplish the works that are mentioned here. And this is a open project for everyone, the difficulty level. If you are a bachelor's, master's, or doctorate, so based on that, you can make an attempt. But if you are intending to do it, you have to just fill a form at the very beginning. So you should find a supervisor or a faculty who will be willing to guide you through the process, and you can just fill in your details with your team members. If it's a team project, expected start date, the project advisor name, and submit it. And later, when you have something, some results, you can upload it, and then you will get the recognition certificate from our team as well. And in case it is, as it is open, if the best project also gets a chance to uh, upload their work through in our MATLAB YouTube channel as well. So out of all the submissions, so we have some of them already. So this is a new initiative. We started a couple of years back.
Okay, sir.
Okay.
Within in 5 minutes, the feedback link will be shared. Sir, we learned the importance of the artificial intelligence in all the domains, especially related to STEM. All it was very informative and interactive. We appreciate the speaker expertise and enthused passion in the domains, as well as uh, the participants' questions. Our heartily thank you for accepting our invitation, sir, and delivering such a wonderful informative session. Thank you so much, sir. Firstly, I would like to give thank you to our speakers for gracing yesterday and today's workshop. Thank you, sir, for your very thought-provoking and excellent presentation regarding the artificial intelligence and the MATLAB, and making this workshop a very meaningful and interesting. I would like to express our deep gratitude to our director, sir, Dr. S.A. Hariprasad, sir. I would also thank you all the department HODs and for the faculty members and dear participants, their guidance and moral support. I would like to thank you, the conveners of Jnana Chilume, organizing secretaries and coordinator department. I'm happy to express a vote of thanks to all the faculty, students, and various participants that has made this workshop a grand success through their motivation and dedication. Thank you very much, sir. Respected sir, faculties, and my dear participants, with this, we wrap up our evening here on behalf of Faculty of Engineering and Technology, Jain, deemed to be University, Bangalore. Thank you for all finding some precious time in your busy schedule to join us here this evening. Have a great evening, sir. Thank you so much.
Thank you, Shivani, and thank you everyone for your kind attention and nice questions. So have a nice evening ahead, and hope this will be of use to you in your near future in your project work and courses.
Thank you, everybody. Have a good evening.
Thank you so much,
Thanks
sir.
for arranging and thanks for organizing. Bye.
I will request all the participants wait for 2 minutes. The feedback will be shared with you. Yes, within 2 minutes, actually, there is a technical issue. Within in 2 minutes, the feedback form will be feedback form link will be there. feedback link is mentioned in the chat box. Kindly fill the feedback form. It is mandatory. Thank you very much. Have a great evening.